Hi everyone, this is Mrs. V Chan. Welcome to my Form 2 Math lesson number 12. And today we are going to have the opposite to Pythagoras theorem, and which is converse of Pythagoras theorem. Okay, so to use Pythagoras theorem, so there must be a right-angled triangle given to us. Okay, and then we can say a square plus b square is equal to c square, and this is Pythagoras theorem. And what is c? C is always the longest side of a right-angled triangle, and then we call that hypotenuse. Okay, so here we have another triangle, but we don't know whether this is a right-angled triangle or not a right-angled triangle. Okay, however, we are given this and saying a square plus b square is equal to c square. Therefore, we can make our conclusion and saying that angle ACB, so this one must be a right angle, so which is equal to 90 degrees. Okay, and the reference is Converse, C-O-N-V-E-R-S-E, of Pythagoras theorem. Okay, so this is today's reference, converse of Pythagoras theorem. We don't know whether this is a right angle or not a right angle. If it is a right angle triangle, that means we must be given this condition. Okay, so example 1, we have to determine each of the following triangles is a right angled triangle. So here, this is a triangle, but we don't know whether it is right angled or not. So 41 is the longest one, so I start with the longest one. So yz square is equal to 41 square. And what is 41 square, which is 1681? So therefore, the other two legs, that will be xy square plus xz square is equal to 40 square plus 9 square. Then I use calculator. 40 square plus 81. So we also have 1681. So therefore, we can make our conclusion and saying that xy square plus xz square is equal to yz square. So what is the answer? Yes, it is a right angled triangle. Okay, and what reference we use here, which is converse of Pyth dots, Pythagoras. Okay, so this is how we prove whether it is a right-angled triangle. So to prove, we must separate the sides at the beginning like that. Okay, so another triangle here, we don't know whether it is right angled or not. So here 10 is the longest one, so I start with the longest one, which is called hypotenuse. So 100, right? So therefore the other two, I have xy square plus yz square is equal to 6.5 square plus 7 square. Then I can use my calculator. 6.5 square plus 7 square is 49, so 91.25. So you can see they are not the same. So conclusion is, since xy square plus yz square is not the same as xz square, therefore it is not. Okay, no, it is not a right angled triangle like that. So therefore, since the answer is no, we don't have any reference for that. Okay, so example 2 here, we also have a triangle, but we don't know whether it is a right angled triangle or not. But what do we need to do here is to find the area. So what is the formula to find area of triangle? So we do this, the base times the height, right, divided by 2. But the condition is this must be a right angled triangle so that we can use the formula. So the first thing we need to do is we must prove whether this is a right angled triangle or not. Okay, so the first thing is to prove. Okay, so this is the longer side. So I start with this is equal to 10 squared. So this is 100. Okay, so the other two, so I have xy squared plus yz squared is equal to 8 squared plus 6 squared. So 8 squared, 64 plus 36. Oh, this is also the same, right? So I can say this is a right angled triangle. So since xy squared plus yz squared is equal to yz squared, and the reason is converse of Pyth dot theorem. Okay, so therefore this one is a right angle. So angle what? Angle y x z is equal to 90 degrees. Okay, and now I can use formula to find the area of triangle XYZ, and which is equal to the base, which is 6 cm times 8 cm divided by 2. Okay, so this is 24 cm squared. So this is how I do this question. If you want to use formula here, make sure that this is a right angle. And how do you know this is a right angle? You need to use this converse of Pythagoras theorem to prove it. Okay, so the next example here, we have a quadrilateral ABCD like that. So the first part, determine if triangle ABD is a right angle, the triangle. So this is ABD, okay, and then I have this 26, which is the longest one. So therefore I can start with this BD or DB square is 26 square, and 26 square is 676. Okay, so the other two sides will be AB square plus AD square, which is 24 square plus 10 square. So 24 square plus 10 square. Okay, I also get 676. Therefore, they are the same. Therefore, AB square plus AD square is equal to DB square. Yes. Okay. Triangle ABD is a right angled triangle. Okay, and don't forget to write your reason here, which is converse of Pyth dot theorem. Okay, so this is opposite to Pythagoras theorem to prove that whether it is a right angled triangle or not. Okay, so from part A, we have proved that ABD is right angled triangle, so we can say that this is also a right angle here. So what shape is this quadrilateral? It is a trapezium. Now I have enough information to find the area of ABCD, and which is also a trapezium. So area of ABCD. Now I can just use formula. The upper side plus the lower side, okay, times the height, which is 10, and then divided by 2, and then I use m squared for the units. Okay, so this is 5, so that will be 24 plus 30, and then times 5. So I have the final answer for area 270 m squared. Okay, we come to the final example in this chapter to finish converse of Pythagoras theorem, and this is the diagram given to us. Okay, so and then what we need to do is to find the distance between x and y correct to the nearest m. So the red line here is x and y. Okay, since we don't know this is a right angle here or not, so I cannot use Pythagoras theorem directly to find xy. Okay, so what can I do? The first thing, so let us look at the bigger one, the bigger triangle. So this is 400 So we know the total length here, and then we know total. Okay, let's prove first whether this is a right angle triangle or not. Okay, so once again, I'll start with the longer side, which is PQ square, same as 400 square, and which is 400 square, 160,000. Okay, therefore I come to this side, PR square plus RQ square. I do substitute. PR square is 60 plus 260 all square plus 120 plus another 120 all square. Okay, so use calculator. 260 plus 60, get answer, and then square, and then plus 240 square. Yes, see? Okay, so same, right? So I can make my conclusion, and since, okay, make it nicely. So since PR square plus RQ square is the same as PQ square, therefore I can say angle. So this angle, PRQ must be equal to 90. So this is 90. Okay, and the reference, Converse of Pyth dot theorem. Okay, so the first thing, I must use converse of Pythagoras theorem to find my right angle here. Okay, now do I have enough information to find xy? I think so, because this is right angle the triangle. Okay, I can find this. Xy square is always the same as xr square plus ry square, and this is just Pythagoras theorem. Do you agree with me? Okay. And then to find xy, I can do substitution. So what is xr square? So this is xr square, so that is 260 square plus 120 square. Okay, so repeat this. Therefore, to get, no, hang on, there is a square here. Okay, so to get xy, I need to take square roots with the whole thing inside. I just copy that again. Okay, and get answer finally with my calculator. So 260 square plus 120. Okay, write it nicely. 120 square, get your answer, and then take square roots. This is square root. So 286 and nearest m. So the answer is 286, and which is the units m. Okay, so that's all about the opposite to Pythagoras theorem, which is converse of Pythagoras theorem. Okay, so thank you for watching my video. I'll see you next time. Bye bye.